There's a storm on Saturn right now that is bigger than the planet you live on, not bigger than a country, not bigger than a continent, bigger than the entire Earth, wider across on our planet from pole to pole, with sides longer than our world is round, spinning at the top of Saturn's atmosphere with precision that has baffled every scientist who has ever tried to explain it, and it has been doing this for at least 45 years. This is the story of the most violent weather in our solar system, the planet that hides behind one of the prettiest faces in space, and why even after 13 years of close observation by a spacecraft we deliberately destroyed in its atmosphere, we still cannot fully explain what we saw. Saturn is the second largest planet in our solar system. From a distance, it is calm, pale gold, wrapped in those iconic rings that make it the most recognizable planet humans have ever photographed. Children draw it before they draw stars. It is a planet you point to when you want someone to feel something about space. But that calmness is a lie. Beneath the haze is a planet whose atmosphere has been screaming at supersonic speeds for as long as we have been able to measure it, whose poles are wrapped in storm features that should not, by every law of fluid dynamics we understand, exist, and whose history holds one specific event that happens roughly every 30 years. An event so violent that astronomers have been waiting for the next one to arrive for the last 6. Start with the wind speed. On Earth, the strongest hurricanes ever recorded peak at around 350 kilometers per hour, and we treat those as catastrophic. Houses gone, cities flattened, lives lost in the thousands. On Saturn, the wind at the cloud tops moves at roughly 1,800 kilometers per hour. That's 5 times faster than the worst hurricane our planet has ever produced. And here's the part that genuinely unsettles atmospheric scientists. Those winds don't just exist at the cloud tops. When the Cassini spacecraft made its final close passes around Saturn in 2017, gravity measurements showed that those supersonic winds extend roughly 8,000 kilometers down into the planet's interior. 5,000 miles of howling, supersonic atmosphere. For comparison, Earth's entire atmosphere, every cloud, every weather front, every storm, sits in a layer about 10 to 12 kilometers thick. You could stack our entire weather system inside a single sliver of Saturn's atmospheric column and have room left over for 10 more. Now look at the North Pole. In November 1980, the Voyager 1 spacecraft swept past Saturn for the first close look any human-made object had ever taken at the planet. As it photographed Saturn's poles, the scientists at NASA noticed something in the images that didn't make sense. A shape, geometric, 6-sided, a perfect hexagon, drawn in clouds, wrapped around the entire North Pole planet. At first they thought it was an artifact, a glitch in the camera, or a trick of the light. Nothing in nature draws perfect hexagons. Storms swirl, they form spirals. They never form polygons. But Voyager 2 saw it 8 months later. And then in 2006, when the Cassini spacecraft arrived at Saturn for an extended mission, the hexagon was still there, almost exactly the same shape, in almost exactly the same place. After a quarter of a century, it is still there today. The numbers are absurd. The hexagon is roughly 30,000 kilometers across, wider than the Earth. Each of its 6 sides is about 14,500 kilometers long, which means each side is about 2,000 kilometers longer than the entire diameter of our planet. It sits at 78 degrees north latitude. It is approximately 300 kilometers tall, and it rotates with a period of 10 hours and 39 minutes. The same period as the radio emissions coming from Saturn's deep interior, which mean the hexagon is somehow tied to the planet's actual rotation, not just its surface winds. At the center of the hexagon sits a hurricane, not metaphorically, a real, churning, hurricane-like vortex with a dark eye, a ring of swirling clouds, an atmospheric structure recognizable to anyone who has ever looked at a satellite photo typhoon on Earth. Except this one is permanent. It does not form, peak, and dissipate the way hurricanes here do. It just sits there year after year, decade after decade. Here is what makes this so strange. On Earth, jet streams meander. They snake. They shift north and south, weaken, intensify, change shape. There is nothing on our planet that holds a fixed geometric form for 45 years. The leading explanation is that the hexagon is what's called a standing wave, a pattern caused by the interaction between 2 parallel jet streams moving at different speeds. Where the fast jet meets the slower air around it, The boundary destabilizes into a wave. And in the right conditions, the right speeds, the right viscosity, the right amount of turbulence, that wave can lock into a six-sided shape. Scientists have actually reproduced this in laboratories. Take a circular tank of water. Spin the inside faster than the outside. Watch the boundary. Sometimes you get hexagons. Sometimes you get squares. Sometimes octagons. The math works. What the math doesn't explain is why it has stayed in place for over 4 decades on a planet whose entire atmosphere is supposed to be one of the most chaotic environments in the solar system. And why Saturn's South Pole, which has the same general physics, the same gravity, the same kind of jet streams, does not have a hexagon or any polygon at all. There's something asymmetric happening at the top of that planet, and we still don't fully know what. And then there's the other thing. Roughly every 30 Earth years, once per Saturnian year, once per full orb around the Sun, Saturn does something unbelievable. A massive convective thunderstorm bursts out of its atmosphere, often without warning. It can stretch tens of thousands of kilometers, wrap entirely around the planet at certain latitudes, and remain visible from Earth for months. We call it the Great White Spot. The first one ever recorded was in 1876, photographed by an astronomer named Asaph Hall. There have been confirmed major Great White Spot events in 1903, 1933, 1960, 1990, and most recently 2010. Each one has been roughly periodic, about every 28 to 30 years, corresponding to Saturn's northern summer. The 2010 storm was the one Cassini got to study up close, and what it found was extraordinary. The storm contained ammonia ice clouds, water ice, and ammonium hydrosulfide. It was generating about 10 lightning discharges per second, and the water in the storm head was being lifted from approximately 200 kilometers below Saturn's visible cloud surface by powerful upward convection. 200 kilometers down, lightning 10 times a second, a storm structure that wraps around an entire planet. The mechanism behind the Great White Spot is still being argued about. The leading theory is that Saturn's outer atmosphere acts like a lid, cold, dense gas sitting on top of warmer, water-rich gas below. Over decades, the lid cools further until it becomes denser than the gas underneath, and then the trapped warm air punches through the lid all at once, exploding into a planet-spanning thunderstorm. If that theory is right, the next one should be coming sometime in the late 2030s, possibly as early as 2038, or in Saturn's southern hemisphere. There was an unusually early storm in 2024 that some astronomers thought might be the Star 1, but it faded after about 6 months without becoming a full Great White Spot. We are watching closely. So now picture our planet, small, blue, fragile, drifting into Saturn's atmosphere. Drop Earth into the hexagon. Our entire world would fit inside a single side of that polygon and still leave thousands of kilometers to spare. Every continent, every ocean, every city, every person vanish into a corner of a weather feature. Drop Earth into the central vortex of the hexagon, and we wouldn't even register as a meaningful disturbance. The eye of that hurricane is large enough to swallow Earth whole and have room left over. Drop Earth in the path of a great white spot in full eruption, and we are simply gone, lifted off the cloud tops. Ammonia, hail, and water ice and supersonic winds, tearing the atmosphere off our planet in seconds. The lightning alone would be enough to vaporize anything we have ever built. This is not metaphor. This is just scale. Saturn is roughly 95 times the mass of Earth, with a volume large enough to fit over 760 of our planets inside it. The weather on a world that big does not play by our rules. It plays by rules we are still trying to figure out. The Cassini spacecraft, the only mission ever to study Saturn up close for an extended period, ended on September 15, 2017. Out of fuel, drifting toward an inevitable collision with one of Saturn's moons that could have contaminated environments potentially capable of supporting life, NASA chose to end Cassini deliberately, sending the spacecraft on a dive into Saturn's atmosphere itself. It transmitted data right up to the final second. Then the supersonic winds tore it apart. Cassini fell into the storm. For 13 years, it circled the most beautiful and most violent planet in our solar system, mapped its rings, photographed its hexagon, watched its great white spot erupt, listened to its lightning, traced its winds, and in the end, it became part of the weather it had been studying. The hexagon is still up there, The great white spot is still building, somewhere in Saturn's atmosphere, waiting for its next 30-year cycle. The winds have not slowed. The lightning has not stopped. Saturn has been doing this for billions of years before we ever looked, and it will keep doing it long after our species has stopped looking. That's the part that stays with you, not the size of the storms, not the wind speeds, not even the hexagon. It's the indifference. There's a planet 700 million miles from us where the weather alone could erase our entire civilization in an afternoon, and has been doing exactly that to nothing for longer than anything on Earth has been alive. We just happen to be the only ones who know. Thanks for watching ASTRAEON. If you got something out of this one, the subscribe button does more for a small channel like ours than you'd think. I'll see you in the next video.